This is where Desmos is fantastic, guys. Okay, circle. I can move it left and right, all that sort of stuff. I can make it bigger and smaller and all that sort of stuff. Here's something we've never ever done. Because technically it's not in schoolwork. Divide by, say, let's go 9. Observation.
It's an ellipsis.
Yeah. And we can talk about the math of ellipse and that, and I haven't done that for a while. But it's not what I want to talk about today. I just want to say, if you had an x squared over 9, how wide is it? What do I mean by how wide is it? It's actually 6 wide. So where is it? Where is it? Can you call it the radius? That halfway across the horizontal axis is how far?
The square root
of 9. And then you know it already definite, but what if I then, just to prove it to you, we go 25. So from the centre to the roots is 5. So what's going to happen if I do that for y?
Same thing.
Same thing. Make sure I get this right way in here, so we make it, I don't know, let's make it 16. So from the centre to the y-intercept is square root of 16. Done?
Yeah.
That's easy. Like really, really easy. It's just like, how much do you understand about ellipses and why doesn't an ellipse work? What shape is it?
In ellipses?
Yeah. Which ellipse?
One that goes out more than it does up.
So this one here, we can say that x is 5 cos pi on 3t. Yeah. So what are we forming?
Cartesian equation.
Cartesian. Y is 4 sine pi on 3t. But we know that sine squared theta plus cos squared theta equals 1. And what has that got to do with those two? Did you already realise? Have you already done it?
Yeah, I've already done one of these in the practice exam.
So we say that cos, so what can we say, sine? So we can now have a look at what's going on. We could talk about, if we wanted to, you could go sine squared pi on 3t plus cos squared pi on 3t if we wanted to be fussy, equals 1. And what's x equal? What's cos equal, I mean? X on 5. Ash, you okay with that?
Sure.
Divide 5, divide 5.
Yeah.
What have we got then? Sine pi on 3t is?
Y on 5.
Y on 4.
Yep.
This will be?
Y squared on 36.
4 squared.
Plus x squared on 5 squared.
Equals 1. Of course I could write x squared on 25. Plus y squared on 16 equals 1. And I've got an ellipse, and what's my ellipse? Horizontal, it goes out to 5 and minus 5. Yeah? Where do you think it goes from? Let's say there, 4 to minus 4. And try to draw your ellipse nicely. I'll draw on the whiteboard. That's the notion of that question. And then we can get its velocity by differentiating. Then we get its acceleration from differentiating. Next thing, Ash, how do I find its initial position? 2 equals 0. So we want R0. What's R0? Should you do it in your head or should you write it down?
It's just 5.
5. Yeah, I will write it for a moment. That's 5 cos 0 of I. Yep. And it's 4 sine 0 of j. And of course that's 0, so we're just left with 5i. So where's it going to start at? There. What else do I want to ask you? Oh, what's its period?
Yep.
The period is 2 pi and n. What's n to this question?
3.
Yeah, and you do it in your head. You don't need to see it written down. I'm going to write it down because my brain is mucking up. So, do it properly. 2 pi times 3 on pi. Pi's cancel, it's just 6. So So if that was the question, it goes out to 5, it goes up and down to 4. It takes 6 minutes, seconds, hours to do the loop. So you can say where was it after 1 second, after 2, after 3. After 3 seconds it's there. And you can do all the stuff of putting in numbers and all that sort of thing. But is that easy? Once you see that question, what is it? An ellipse. Do we need to go through the stuff of going it's out to 5? Well, often they'll ask you to do the Cartesian formula. So you're going to get that anyway. And the moment you see that it's 5, but you knew that was 5 anyway. You're right? So the I part is the horizontal intercepts. Twice that is the length of it horizontally. Twice that's the length of it vertically. Questions done? They can go all the other stuff, you can keep going and going about what it is. So by the way, if I made that a 5, what would happen to it?
Be a circle.
Be a circle. If I made it a 15.
Then it'd be really tall.
Yeah. Does the period change?
No.
No.
Usually, I notice that they ask you what the direction of the motion is.
Yeah. So which way is this going?
How would you figure that out?
Well, one way you can do it is just to say where would it be after? If that's 6. So it's after 1.5 seconds, would it be there or would it be there? And we want to do calculations like that. What about after 1 second? What would R be after 1 second? So, say you're really stuck, horrible question, it's not as obvious as this one, and you want to do it, you can say where is it after 1 second? And we've got 5 cos of pi 3 I plus 4 sine of. How quick are you at pi 3?
Half.
So that one's a half. So it's 5i a half, what do I write a half of I? Sine of pi 3?
Root 3 on 2.
Yeah. Okay. We're at 2.5i plus 2 root 3j. So is that helpful? Maybe.
So it's going down.
2.5i plus 2.3j. There it is then.
Oh, it's going up.
After 1 second. So yeah, we could talk about velocity and muck around with it and see what's happening with the velocity. So you could get the velocity when the time was 0 and go through the same process. So what would you do if you didn't want to do it like that? So its direction is that direction. And they'll say what was its initial velocity. So what's its velocity? Be careful. 5 times that. 5 pi on 3, change the cos to a sine, go the way my brain operates. Pi on 3, 2 doesn't change with an I. You've got to remember that cos becomes a minus sign. My logical process, it stops me making all the dumb mistakes. So what have I got? 4 times pi on 3. Yeah?
Yeah.
Sine becomes cos, and it stays pi on 3 with a t, and that's j. So what's the velocity at the start? Sine of naught is?
Naught.
So I should stop saying naught. Sine of 0 is? Sine of 0 is 0, so that's naught I. Plus what?
4 pi on 3.
Times by the cos of?
0.
Cos of 0. Just take my time for a moment if I'm making too many stupid mistakes. Cos of 0 is?
1.
1. So its velocity at the start is 4 pi on 3j.
So it's going directly up.
Mm-hmm. So is it quicker to do that? Well, you're probably going to be asked all the time to differentiate to get that. Or you get that and you integrate to get that, and they give you some values and you substitute to get the C value. You okay?
But that wouldn't be in the non-calc, would it?
Oh,
Could be.
always ask. Look at this face. I can be so mischievous. So the velocity at 0, the velocity at time 0 is 4 pi on 3.
So it has to be going that way.
Yes. Where would it be after 6? Let's say it's seconds. So we're talking about t or seconds. Where is it after 6 seconds?
Back at where it started.
Yeah. Where is it after 3 seconds?
Halfway.
Doing 4 pi on 3. Negative.